This week we're going to work with solving systems of equations by substitution. The main reason why we're doing this is because, as you found out from our POD last week, that sometimes solving by graphing is not the most feasible of methods to use. So first we need to talk about what it means by substitution. What we mean by substitution is solving one equation for a variable and then replacing that variable in the second equation with what it's equal to. Now I know that sounds kind of complicated, but I think once we start going through some examples, you'll get the picture. So let's first start about talking about this first simple one like this to refresh your memory, that because it tells us y equals 3, we're going to go ahead and put that in for y, which means that x plus 3, because x plus y and y equals 3, is equal to negative 32. So then we would, like we know how to do, subtract 3 from both sides, giving us x is equal to negative 35, which would therefore make our solution to this equation negative 35, 3, because those are our x, y values that they're equal to, which we write as an ordered pair. Moving on to something that's a little bit more challenging and a little bit more involved, which is the basis for our lesson today. We're going to take a look at y equals 2x plus 1 and 3x minus 2y equal to 6. Step 1 for this problem is going to be to box around the expression that is solved for one variable. And what we mean by that is that we see that y is all by itself, and it says that y is equal to 2x plus 1. So we're going to box that in because that's going to be really important for us in this problem. Step 2 is going to be to box around the same variable in the other equation. Now that also sounds kind of confusing, but what we mean by that is since y has already been solved for here, we're going to box in the y in the other equation, being that they fit together. Step 3 says we're going to replace the variable with the first box. So explaining that a little bit further in depth, it means we get our 3x minus 2 and then y, which is equal to 2x plus 1, is equal to 6. So all we have done is taken this value that we've gotten for y and sticking it in for the actual y here. We're substituting. So then we can go ahead and bomb the 2 out, which will give us 3x minus 4x minus 2 equal to 6. So we've started step 4, which is to solve it. So if we keep on going, I see that 3x minus 4x is going to be negative 1x, or negative x, minus 2 is equal to 6. So then I can add 2 to both sides to give us negative x is equal to 8. So then we have to divide by negative 1 on both sides to get x is equal to negative 8. So then, once we have completed that, we're then going to solve for the other variable. So now that we know that x equals negative 8, I'm going to take that and put that back into this first equation to get y. So it tells us that y is equal to 2x, or 2 times negative 8, plus 1. And so then y is equal to negative 16 plus 1, which equals y equal to negative 15. So that means that my ordered pair solution is going to be x, which is negative 8, comma y, which is negative 15. Now as you can see, that's kind of a big ordered pair, so that is exactly why we use our skills of substitution rather than graphing. Then finally, step 6 is going to be to check your solutions. So if we go back through, I'm going to do my check over here. So if I go back up to my equations so I can see them, I have that negative 15 should equal 2 times negative 8 plus 1. So I go ahead and 2 times negative 8 is negative 16 plus 1, and negative 16 plus 1 does in fact equal negative 15. So I know it works for the first equation. And I can go ahead and with the second equation, and 3 times negative 8 minus 2 times negative 15 should equal 6. 3 times negative 8 is negative 24, minus 2 times negative 15 is negative 30, equal to negative 6. Chunky plus, because adding the opposite, negative 24 plus 30 does in fact equal 6. So I know that I am correct.